All right, so I think this is a fun topic because we can get into what we call a little bit of a religious conversation, which is when to select hyper-converged infrastructure. It's almost like saying when to select virtualization for a solution. Is there really a bad time to select a virtualized environment or a hyper-converged environment? You know what the answer is? It depends. A lot of the time, not all the time, but a lot of the time, the argument is not necessarily technical. And I think I'm probably a good selection to talking about a discussion that dips in and out of the technology a little bit. And we'll get into why I think this is a topic that's near and dear to what I do day to day. So, unlike Scott Lowe, I haven't written 7 books. So you don't know who I am. So we'll spend a couple of minutes talking about who I am, why I'm up here talking to you about hyper-converged infrastructure. If you might have known me in a previous Twitter life or previous blogger life, I'm traditionally virtualized geek. So a lot of the traditional community content was around how-tos, you run into a problem or you want to do nested NSX in a lab. That's the type of stuff that I would have done on the Virtualized Geek channel. Over the past few years, I've moved out of a pure technical role into more of a business-focused role. That began maybe about 5 years ago now. I became the chief architect for one of the programs Lockheed Martin had providing to the US government. In that role, I was kind of abstracted away from the day-to-day technology while I was responsible for doing traditional solution architect stuff. Much more customer focused, a lot of project management, a lot of business case development, trade study analysis, getting away from the day-to-day keyboarding. That progressed. I went to PwC. If you attended the noon session with me and Scott Lowe, you will have heard that at PwC, the argument, and for those of you who don't know the acronym, PwC is PricewaterhouseCoopers. They changed their branding in the US and globally to PwC a few years ago. I walked away a little bit even further from the data center and that day-to-day job. And the typical conversations were no longer, should I go with NSF, iSCSI versus fiber channel. Those arguments were no longer the arguments we had with clients at PwC. The conversation was, should I outsource all of my IT to a managed service provider and let them worry about the NFS, iSCSI, and fiber channel conversation? So it gave me a unique view from the business side of how decisions are made. So for this conversation, we're going to dip in and out of technology and business to understand what are some of the drivers behind making a decision on a hyper-converged infrastructure. And then at the bottom is some housekeeping where you can find more of my content, virtualizedgeek.com. I still blog over there whenever I get the urge to scratch the geek part of my DNA. I can't get away from it. I still enjoy just doing random stuff like trying to run Azure Stack and vCloud Air. Why would anybody want to do that type of pain to themselves? I'm that guy. TechRepublic.com, which is a larger for-profit endeavor run by a big US broadcasting company, the CTO Advisor, which is more around the topic that I'm talking today. And TechTarget, I think we all know TechTarget fairly well. They're a pretty good resource within the community. So I don't know if this is the case here. I think I get a sense that it is. One of the interesting things that I've learned in conversations with you guys over the past day or so is that virtualization is a given. Most environments are 80 to 100% virtualized. If you can't virtualize it, why would you want it? And that changes the argument for hyper-converged infrastructure a little bit. But I think from a business perspective, the thing that I think is common throughout Western culture is that application teams are having a bigger voice in the infrastructure, kind of outsized than what we've traditionally expected in this x86-based world. It's been, for the most part, I think the Nutanix folks did a great job in the presentation talking about monster VMs, Mike and Josh, where they talked about the application owner saying, you know what, I need a 96 gig VM with 20 cores. And the application probably only needs 16 gig of RAM with 2 cores. And we've fought that battle in the past, and to this point, I think we won it. We've proved virtualization out. That virtualization in a shared infrastructure, most applications can live in that well. But what I'm starting to see is application providers such as Oracle, SAP, going straight to the application owner, and especially in Oracle's case, is selling a full stack. So storage, compute, networking, as a single appliance, what they call an appliance. And I see parallels from this appliance approach in the hyper-converged market. So we'll talk about my experience dealing with application owners from the SAP side of the house, specifically SAP HANA. Again, Josh and Mike did a really great job giving an example of an SAP HANA workload. An SAP HANA workload, at the minimum, I think the slide that they had 20 to 40 cores and 128 gig. I think my experience has been, even in that might be a good test environment, but production, 256 gig. You're talking about a scale-out environment, 256 gig, and the number of cores, debatable, 20 to 40 is probably a pretty good number. So we'll talk about the parallels, and the business side of making the decision to go with a HANA appliance or a BYOD, or bring your own data center approach. By the way, I mentioned this in the afternoon session. I can talk. Not only am I loud, I enjoy talking. If you don't interrupt me and ask questions, I'll just go right through. So please feel free to raise your hand if you have any questions. I really like this slide. This is provided by the folks at Wikibon. They spent a lot of time looking at the x86, what they initially called the server SAN market. The server SAN taxonomy never caught on. Server SAN is basically x86 storage, scale out storage. What we've seen in different solutions, I have what we call a NASCAR slide with different options. But the interesting point that I wanted to show on this slide is that somewhere circa 2020, 2021, server SAN or x86 based storage will start to outsell traditional storage arrays. So there's a lot at stake. These revenues are in the millions. So, we're talking about a $40 billion market, and server SAN taking half of that, software taking half of the market from the traditional storage guys. So, slide for an effect. So let's start off the conversation with level setting on what's hyper-converged. If you blog and you've ever written about hyper-converged, chances are a vendor has emailed you in response, some vendor you've never heard of, and said, you know what, our solution is hyper-converged too. And you're like, wait, isn't that like open source server SAN software from 1999? You guys, how are you hyper-converged all of a sudden? So let's level set on the definition of hyper-converged. A virtual storage array, so your typical 3-node minimum storage x86 cluster, with hypervisor software running on those units and management software to manage the deployment and administration of the hardware cluster. So the storage level, the hypervisor potentially, and then obviously adding on to that. So every time I want to add a node, I go into some type of administrative console, click next, whatever, and I've expanded out my hyper-converged infrastructure. Any debate or objection to that definition? You guys are great. This is going to be a great dictatorship. I like Australian culture. All right, hyper-converged versus converged. So what's hyper about converged? It's hard for me to get hyper. I'm from Chicago. It's 11 o'clock. I got in yesterday, and it feels like 11 o'clock. My bedtime is about 10:30, so I'm going to do my best whenever I say hyper to, let you feel it. So a converged system has similarities. The difference in a converged system, again, your definition may vary, but this is a great dictatorship, and I'm enjoying being the dictator. Has compute, network, and storage that's engineered tightly together with a management overlay. So normally, you'd have some type of centralized managed solution. So these are completely independent systems. We'll pick on one of the VMware communities or federation companies examples. For example, VCE, the vBlock is a great example of a converged system. You have Cisco for your network and compute. Then you have VMware for your hypervisor level and layer. Somewhere in a factory, someone has engineered, they spec'd out your solution, and they put it together and they've engineered it in a way that it should run extremely well. And we'll get into the advantages of that from a support model. So examples of that from an industry perspective are Oracle RAC, SAP HANA, we call them, in the SAP world, we call them appliances. They're not really hyper-converged. Converged. A lot of vendors will sell their converged solution as a SAP HANA product. An example is HP, their Converged System 7000, which is basically, or their, I forget the names, I think the Converged System 9000 is a Superdome X, some 3-part storage, and some HP switches. They engineer together, they go to SAP, say test this configuration. SAP tests the configuration and says you are blessed to run SAP HANA on this platform. And then the third option, which is bring your own. What we've been doing in the data center for years. Obvious question is, can I build my own hyper-converged solution? If you went to Chris Wall's PowerShell demonstration, you'll see, and even in the NXS session in this room a little bit before that, the scripting tools that we have available are incredible. I mean, if you're a Windows administrator, as I am typically, I cut my server administration teeth in the Windows world on Windows NT 4.0. And the concept of what you can do, I can write a heck of a batch file. I mean, you would be amazed at the stuff that I can do in the batch file. But nothing near the level of automation that I can achieve with PowerShell, PowerCLI that we use in the VMware community quite a bit. I would guess that if you worked hard enough, you could create a product that looked a lot like a hyper-converged solution. But for the most part, it's really tough, and it's probably not worth the effort to try and emulate the stuff that the vendors have done from a management level. So from a BYO, bring your own hyper-converged solution, For the most part, the big difference is the lack of the management capability. So we have the virtual storage. We can go out and get a Scale IO, which is completely free, build a server SAN, pretty capable server SAN, on top of VMware vSphere, Hyper-V, and I don't know if they support, I don't know if Scale IO supports KVM, and then still run our hypervisor workloads on top of those same x86 storage platforms. And it looks a lot like Hyper-Converged. We can pick on vSAN. It's vSAN Hyper-Converged. VMware has started to market vSAN as a hyper-converged solution. For the purposes of this definition is we're managing tightly the hardware and hypervisor level, so vSAN didn't make the cut in my definition, sorry. Before I go on, you guys are really not working hard to win these Apple TVs. This is an exciting topic. I think I'm not doing it justice. And the Apple TVs. So I'll go back and look at the video and see what I did wrong, but we'll get there. All right, so who are the hyper-converged players? Where can I get it? I don't have a slide or a projector big enough to show all the players who claim to be hyper-converged. But these are, off the top of my head, some of the more obvious names in the community. A couple of the vendors are sponsoring today's VMUG, UserCon. It's curious, I put HPE. They beat me up if I say HP Enterprise. HP actually has a hyper-converged solution, I'm told. Scale Computing, we'll get it in Dell, and we'll get into the details, a little bit of these different vendors. And then VMware has their EvoRail, their EvoRack reference platform. I think most of us in the room are engineers, and it's all about requirements. If application owners and business people could always just give us the right requirements, our solutions will be dead on every time. It's all about not getting the right requirements, and choosing hyper-converged over one of the other two options is, again, about requirements. I put performance, scale, and support in the primary requirements. Cost, we're engineers, we don't care about cost, we care about delivering the right solution. Unfortunately, we live in a world that requires cost, so I will cover cost at the end. So let's talk about performance. One of the things that I loved when I got off the airplane was that I saw, I'm not a car guy, so to speak, but this Holden brand from GM, I was really excited to see the different variations of the cars I love in the US. Here, one of you guys drive on the wrong side of the road, which is confusing. I'm a runner, so I have to really think about not getting hit when I go run in the morning. But the other thing is that the variations on the different cars are amazing. When I got off the and there's a what we call a utility vehicle, and I think you guys call it util. Ute. And I would have called it a El Camino SS, and it was very similar. I thought, man, that's really cool and really throwback. Then one of your VMUG leaders, Ryan, gave me a ride back from the airport in his car, and it's really fast, and the sedan is just really exciting. So from a performance perspective, hyper-converged infrastructures can rock. I mean, these things can perform. They are built on the same technologies that we've loved for years in VMware. I'll harken back to the Nutanix presentation, and I have to stop calling it Nutanix because Josh and team did a great job, Josh and Mike did a great job of not selling Nutanix. They sold the concept of virtualization. That if you want, you can scale up your storage array to provide 1 million IOPS to a single VM. It takes 2 flash arrays, but you can do it. So you can build anything you want from a performance perspective and hyper-converged. A lot of the advantages from a technology perspective for hyper-convergent performance is the disk is tied with the compute. One of the advantages of SAP HANA is that you've combined the database with the analytics and CPU. So there is no latency going from disk to CPU. And HANA goes one step forward. It's in memory, so you even get greater performance from a latency perspective because you don't have the latency of the flash bus. You're processing from memory. So the closer you can get, it's basic computer science. The closer you can get the storage to the CPU, the better performing the application will be. Hyper-converged is no different. So when hyper-converged was first introduced to the industry, a lot of the initial use cases was VDI, because VDI is read heavy. I remember a lot of the first white papers was around combating boot storms, read boot storms when you're booting up 800 VMs first thing in the morning. These things haven't changed. On the flip side, one size doesn't fit all. If you've ever tried to solve a problem just by adding flash to a system, that doesn't necessarily solve the problem. Adding a higher speed I/O doesn't necessarily reduce write latency. There are what I call nerd knobs, and my good friend over at the Packet Pushers calls it he wrote a blog post that called it something a little bit different than nerd knobs. I won't repeat it on stage because I'm recording myself. But basically, when you need to tune for performance, and this is a generalization, most hyper-converged solutions don't give you the knobs to make those adjustments. And obviously, one of the big things is lack of support for in-memory database. It's not from a tech, and this I might hit on it yet again. It's not, you do disqualify yourself if your phone go off for the Apple TVs, just so you know. The problem isn't a technology problem. It is a perception problem. You guys this region have done a great job of eliminating the perception problems when it comes to support of VMs for your mission critical apps. Unfortunately, in-memory databases, specifically SAP HANA, from a certain workload perspective, has not. So while we can virtualize those workloads, to get support on that from specifically SAP, the hardware ACL is very strict, and they don't support hyper-converged. I don't think there's a hyper-converged vendor yet that has gained SAP HANA certification. Let's talk about scale. Snapshots. Just to give you guys an idea of how big some of these solutions can scale. Nutanix announced one of their largest deployments, 1,500 nodes. I don't know the details around it. I don't know if that's 1,500 nodes. I don't know the architecture. I don't know if that's 1,500 nodes in a single cluster. I don't think it's really important. Just the idea that a Nutanix customer has 1,500 nodes in a single environment. Simplicity. They recently announced a deal in October. I don't know if it's deployed. That's 4 months plus of 200 OmniStack systems. And then on the SMB side, scale. Largest customer or largest configurable cluster is about 4 nodes, or roughly 200, 250 VMs. One of the considerations when it comes to hyper-converged architecture is scale out versus scale up. Most hyper-converged solutions, very modular. We can take a brick, what I call a hyper-converged brick, add it to your existing infrastructure, continue to scale that infrastructure out. So if you're in an environment that can leverage scaling out from a performance perspective, that performance is usually pretty linear. I can keep adding bricks and keep increasing my ability to increase performance. So if you're in a very parallel environment, scaling out and hyper-converged, very good solution. First is scale up. Again, this is a generalization. Once you buy it, there's very few systems that allow you to go back and add individual components. And this is a hard computer science problem. You know, if we think about it from a, one of my favorite industry terms to think about or talk about is erasure coding. I hate the term, but basically this ideal that I add parity to protect data. When I think about it from a brick level, if I add more bricks, erasure coding is pretty simple. I just spread the parity across I rebalance my cluster, and the parity bricks are written across, or the parity bits are written across the new nodes that I add to the cluster. But what happens if I take a single node and I add disk to a single node? How does that impact erasure coding and parity?
Puts a skew on your data locality.
It's a hard computer science problem. Or if I change memory in a single node in a cluster. These things are highly engineered to work together well. When I change one part of that system that wasn't meant to be changed or customizable post-factory config, I add complexity to the environment. This is one of the nerd knobs we talked about. Some of the advantages to the software-only solution. I had a great conversation with Rolison Rivera from VMware. He works in the office of the CTO. He was on the podcast, and we talked, and I asked him this question. You know, why the static configurations with vSAN when it first came out? And he walked me through kind of these hard computer science problems, but the advantage of software is that you can fix these problems. And this is not unique to VMware vSAN. Nutanix, Simplicity, Scale, all these vendors will, as the products mature, they get more data from customers, they'll also be able to solve some of these challenges. But generally speaking, scaling up is a challenge in hyper-converged infrastructures. Any questions on scale? This is usually a hot topic.
So isn't this just basically the nature of Intel? You might as well go back to the mainframe. So you've got this big lump of compute and the system knows how to deal with it. This is...
So I'm an SAP guy. Now I'm an SAP guy. I'm an SAP guy because that's I got a great question of why did I choose SAP as a career? SAP infrastructure? Because the SAP team has a lot of money. Just plain and simple. It's a simple thing. Follow the money. And actually posed that question to the team, which was SAP, if I was not going the HANA route, runs on AIX, why not just buy a Z13? This is a nice system, and it's super reliable, and you can't get much more converged than that. So yes, good point. So this is going to be a competition. This is not a $35 Chromecast. He's leading. And he brought up mainframe. So the bar is low. All right, support. And I think support is one of the big areas when we talk about hyper-converged versus the other two options, or mainly BYO. The ability to pick up the phone and say, vendor, I would like to say network, but hyper-converged doesn't really include network yet, but my storage is performing poorly. Or my hypervisor isn't doing what it needs to do. Or I'm getting hardware errors from the disk. You have one, we like to call it throat to choke, or one single point of contact. With converged systems and hyper-converged systems, the burden of support is a huge relief. This is why SAP HANA today doesn't run on hyper-converged platforms. Today, if I bought a SAP HANA appliance, and again, I use air quotes when I say appliance because it looks very much like a converged system. Excuse me. If I bought a SAP HANA solution, I had a problem. And I think HANA and Oracle are great examples of kind of the ultimate level of support when it comes to this model. Let's say that the application team made a change. I'm sorry, in the back.
Okay, if one throat to choke is a big benefit of hyper-converged systems, does that change when you buy Nutanix on Dell or SimpliVity on Lenovo? Because you're not buying the whole system from one vendor then.
You are actually still buying one system. Most of those models, I'll let those specific vendors talk to themselves. But when I talk to Dell about Dell, the same question, Dell's the throat to choke.
Okay, but Dell's not the expert in the Nutanix software. It's the software that is the secret sauce and the hardware that's commodity.
So this is where
And by choking the right throat.
So then that's a valid question, and I think that the SAP HANA example is a great example. So let's say the application team, by the way, we have two people leading the way for the Apple TVs. One asks a SAP HANA question, and the other one asks the mainframe. We're getting better, but come on, guys. If I bought a SAP HANA appliance from, let's say, Dell, it's a series of, let's say it's a Cisco or Dell switch, Dell storage, and Dell compute with SAP HANA running on top of Red Hat, RHEL, or SUSE, doesn't matter. The application team makes a change over the weekend, changes a query, and a query that was taking 13 seconds is now taking 13 minutes. They pick up the phone, they call SAP, not sure if the problem is the problem with the query, or if there's a problem with the underlying storage, or if we're having a configuration problem and RHEL, we patched the system the same weekend as well. We just have poor change control. We made two major changes in the same weekend. This support model, SAP owns the entire stack. They have Dell sitting in the next room, and they will have the SAP guys go and look at the application guys, look at the query changes that were made, and then concurrently they have the Dell guys looking at the hardware. I'm not privy to how Dell and Nutanix set up their relationship, or SimpliVity and Cisco, but my understanding is a similar relationship, that the support teams are tightly integrated. So very good question.
Yeah, similar to what VCE does, right? You just pop one finger.
Yeah, that's exactly to how VCE does. They don't, there's not many Cisco guys, Cisco employees working at VCE. There's a very tight support arrangement.
Are there any questions on VCE? I'm happy to answer.
See the
VCE support model, part of a PS guy at VCE, not trying to blur the line. Did you have a direct question about VCE, the support?
Yeah, our sponsors, their sponsors here for Dell, Nutanix, SimpliVity, they can most definitely answer that level of question. But that was a very good question. So let's get to one of my leg slides. Let's talk about cost. So I told you guys I spent 2 years as a management consultant. At the end of the day, you know what I learned? There's no such thing as saving money. It's a fool's errand. You move it from one bucket to another bucket. You're either going to spend it on OpEx or you're going to spend it on CapEx. Vendors will disagree with me, but we've done this analysis time and time again. You can make these numbers say whatever you want them to say, but generally speaking, you're not going to save money. Everything is relative. What I have here is a relative chart. So I built kind of this model that said 0, 50, 100. So your scale is your small organization. This is the caveat. If you're a small organization and you go out and buy a converged system, you're probably buying the wrong system. There's a minimum footprint for a converged system. So if you go out and buy a converged system versus a hyper-converged system, in most cases, or a BYO, a bring your own, you spent more money than you probably had to get the solution. Now, requirements can drive that to be different. If you're in an organization that says ERP cannot go down, and you spend $500,000 to get into, and I'm making this number up, you spend $500,000 to get into a converged system versus $100,000 to get into a hyper-converged system, and there's virtually no difference in uptime between the two systems from a technical perspective. It's been my experience. Executives feel more comfortable when they've spent the 500. It's, when you put the weighted calculator in front of somebody, oh, this calculator feels, it's heavy. It must be good. Same concept. If you were to right-size the solution and bought a BYO system versus a hyper-converged system, you'll probably spend roughly the same amount you might spend less in CapEx, but you'll end up spending a little bit more in OpEx, and the difference becomes negligible. There's a reason why I showed the application slide at the beginning. SAP HANA deployments for a large organization can be anywhere from 20 to $70 million. Infrastructure costs in that will be anywhere from $5 to $20 million. You're not going to squeeze savings out of the infrastructure for that type of project. So when the application team is driving the project, they're going to look at infrastructure and say, you know what? The cost isn't, this is why I didn't even have cost on the title slide. Cost isn't the factor for infrastructure. I'm trying to figure out how I can get everything off of Oracle and onto HANA so I'm not paying two database charges. That's where the real cost savings is at. So when we talk about infrastructure costs, especially if you're looking at some of these higher-end hyper-converged systems, it's been my experience that there's not an awful lot of cost savings. Any questions on?
Doesn't this come down to the nature of workloads? No one is writing software that's designed to really scale out. Amazon is allowing you to spin up a lot of things which cater for the way people have always done workloads, but no one is saying let's reinvent the way we do work. So
you're solidifying your Apple TV here. So I like that conversation. One of the advantages of hyper-converged over something like a scale-out, a true scale-out or web scale or cloud-native application is that we can buy a hyper-converged infrastructure and not change the way that we deliver applications today. It's invisible to the application layer. So in an earlier, and I'll ask the question here, how many people in here have containers in production? That's telling, the answer is none. And that's telling in the part of the world that really embraced virtualization. Hyper-converged is just another way to do what we've always done. The biggest difference is in, I think, the biggest difference is in support. And simplicity. I really like the fact that simplicity named there's something named VC. I have enough problems talking. I can say those two things in the same conversation. I think one of the biggest values of hyper-converged and converged infrastructure is the support model. Is the ability to call a single organization to get support. The scale-out piece of the architecture. You know what? The simply adding infrastructure is nice. I don't buy into that as much because I don't have environments that need to scale from an infrastructure perspective that often, and that So taking 15 minutes to install, to expand the infrastructure versus the wait time of working with my MSP to have it done in 1 month. I have bigger problems than that. That's not solving a problem for my environment. So for me, that's not a big deal. But the great thing about Hyper-Converged, it doesn't change how we do or what we do today in the data center as far as application delivery. All right, so last slide in question. So when do you select Hyper-Converged? You guys are in the day-to-day, when do you do it?
But you got a bucket of money spent.
Why not now?
Why not? Why not? So
Yeah.
why wouldn't you, let's reverse the question. Why wouldn't you select Hyper-Converged? If I made the argument that the cost is cost neutral, that you're either going to spend the money in OpEx or you're going to spend the money, these Hyper-Converged hardware vendors are pretty smart. They know how much you spend in OpEx and they know what the tolerance is or what they can charge before they start to eat up all of your OpEx savings. So when is it not a great time or a great use case to buy Hyper-Converged?
Depends on the workload, it depends on the licensing model that you have. If you've got something that's locked in, big process driven, then it's probably not a good time, because it depends on the workload again. And the pocket.
So, a great example of this, you guys remember when Blade Systems first hit the scene? Great idea on concept, but to make it economically feasible, you had to almost populate the whole thing out the gate. So there was this minimum buy-in to get into Blade Systems. If you didn't, let's say something modern like a C7000, I think holds, I'm an Itanium guy. I know a C7000 holds 8 Itanium blades. I don't know how many x86 blades it holds. I think it's 16. I like spending a lot of money on legacy hardware. There was a point that if you didn't at least have 8 blades in there, that it just wasn't cost effective. I think Hyper-Converged is pretty much at that same point when it comes to performance or value per dollar spent, which is.
One of the points you haven't touched on, and from a small to medium enterprise point of view, it's not about necessarily how cost neutral is, it's about storing the resources. So if you've got a team of 10 people looking after your enterprise, you've got to have, and you've got an old-fashioned SAN with bloody wires everywhere and brocade switches and stuff, you've got to have 2 dudes who know how to drive that thing. All of a sudden with Hyper-Converged, you can repurpose those 2 blokes and have them do something else.
But you've lost your nerve dogs.
Hey?
But you've lost your nerve dogs for when things go.
You have, but again, it depends on your workload, on your circumstances, whether or not you need those.
So the question has been, if you go with Hyper-Converged and you're an SMB and you've dedicated resources to, let's say, SAN administration versus server, you have these traditional silos and you go to Hyper-Converged, you're able to get rid of the silos. Good point, you're fundamentally able to change your IT organization. My argument, and this would bear out, and I haven't done it for SMB, but it would be an interesting exercise to do. If I went with, let's say, a scale solution, which is at a certain price point and gets rid of my SAN, and I have the right workloads, gets rid of my SAN, gets rid of my network complexity, and then and potentially gets rid of, you can to make this argument to you too, gets rid of my VMware licenses. Have I saved enough to repurpose those guys? I think that's something to consider. I think that's worth having an extended conversation over once we're done, because I think I'm pretty much out of time. I think I have time for 1 or 2 questions.
Any observations on kind of more exotic hyper-converged architectures like data core? I mean, it's a nice story that you kind of use all the cores and treat them as memory, but that's kind of exotic. And I thought the whole hyper-converged play was about commodity.
And I don't think the hyper-converged play is as much about money as it is and a lot of the vendors will tell you, it's about future capability and going beyond just the infrastructure. And as you start to provide APIs and consuming this goes into a whole nother talk and conversation. But when you look at the data center as an API-driven thing, and the underlying, and HP calls it composable infrastructure, and I take something like the machine and have a data center that in a computer, and the data center is just one big computer, the Kubernetes approach and all that, that becomes an interesting thing. So I think that goes beyond hyper-converged, and I think even from an infrastructure perspective, we're not quite ready for what that looks like from an operational perspective. That's really cutting edge and on the leading edge of what we're, I think, accustomed to managing. But I'm a architect, so I like looking 5-6 years out, and I think that's a great look out on what happens when the whole data center is a single cluster or a single resource. Any questions? So I get 2 winners for the.
Yeah, but it's called the mainframe. I just want to bring that in again.
Yeah, yes, it is called, and we went back again to the mainframe. Guys, it's been a wonderful VMUG. Thank you very much for hosting me.